Well, I'm here to tell you about a real search for alien life. And I'm not here to prove or disprove the existence of UFOs. By the search, I'm not talking about signs that aliens have visited Earth. I'm actually here to tell you about planets we're finding, planets beyond the solar system, planets orbiting stars other than the sun. We call them exoplanets. And what we plan to do is find rocky planets where we can look at their atmospheres with sophisticated space telescopes looking for gases that don't belong that we think might be produced by life. And that's how we're going to find life on other worlds. Now, we're not going to know if those gases are produced by bacteria, simple life, or more complicated intelligent life. But that's the plan that we're trying to carry out in the next decade or more. Every star in the sky is the sun. And our sun has planets. So we should naturally expect that other stars have planets also. And they do. In the last 20 years or so, astronomers have found thousands of planets and exoplanet candidates. We've also found the statement to be true that every star in our Milky Way galaxy should have at least one planet. But after all that hard work over many decades by hundreds, if not a couple thousand people, we found that our solar system is so rare that we haven't yet found any copies of it. What we have found instead are incredibly diverse planets. We found planets of pretty much every imaginable mass or size or distance from the star. And we found some really crazy planets out there. There are rocky planets so close to the star, we think they are heated to such high temperatures that they'll have liquid rock surfaces. That's like molten lava lakes covering their surfaces. We found planets that we think could be made of half water or more. And these planets may have water in a form that's not common on Earth, not quite a gas, not quite a liquid. We found planetary systems where there would be 5 planets, all packed together, all orbiting to what would be interior of Mercury's orbit. We found planets that orbit 2 stars. A lot of these discoveries are from the Kepler Space Telescope. But you know what? The list of surprising discoveries in exoplanets is so long, it is simply astonishing. And there's just no way I could do it justice here today. But what I did want to tell you about was, out of all the stars and all the planets out there, the planets we most want to find are the ones that may have signs of life on it. So all life on Earth requires liquid water. So we're going to be terracentric, and we're looking for planets that could have surface liquid water. And rocky planets are heated from the outside by their stars. So we're looking for planets that are the right distance from the stars, so they're heated to be not too hot, not too cold, but just right for life. And those planets would orbit in a zone from their star we call the habitable zone. So one of the questions I get asked most often, besides questions about UFOs and aliens, is do we know of any habitable planets today? Are there any that we know about that I could tell you about? Well, it just so happens that there's like 1 or 2 dozen claimed potentially habitable planets. But I guess the question for now is, are these habitable? Are they inhabited? And I have to just tell you that there isn't even enough information for me to speculate right now. These are artist conceptions. These planets are found indirectly, just by their effect on their star, but we do know something about their mass or their size, and we know that they could be in their star's so-called habitable zone. What we really want to do is to be able to look at the planet's atmosphere, to evaluate what gases are in the atmosphere and how powerful of a greenhouse the atmosphere is, to really understand if the planets are too hot, too cold, or just right for life. But what is so amazing is that as soon as astronomers were able to even find out if there were any kind of potentially habitable exoplanets, all of a sudden there's like a dozen candidates. So in exoplanets, it's just history that when there's one, there's more. And so it won't be too long before we have lots and lots of these things. So in our own Milky Way galaxy, there are hundreds of billions of stars. And in our universe, there are upwards of hundreds of billions of galaxies. So if you just do the math and ask how many stars are out there and how many planets, it somehow seems inevitable that there are planets with life out there somewhere. So the question that we're facing today, actually, is how do we find and identify the habitable planets? We want to build essentially on decades of work for planetary systems and for Earth itself, and to look at their atmospheres for gases, try to find gases that don't belong that we can infer may be produced by life. Well, there are 2 ways to there are 2 ways to look at exoplanet atmospheres. One that's going on today, that is, we are going to extrapolate and carry down to rocky planets orbiting small stars. And these are planets that transit the star. They go in front of their star as seen from the telescope. And to do this, there are many ways to go out there and find them, including here at MIT, we're leading the construction of a space telescope called TESS that's going to launch in 2017, and it will look at hundreds of thousands of stars looking for rocky planets going in front of small stars. And what's so great about this technique is that when we see the planet and star, we just see a point of light. We don't see the planet itself. But through indirect techniques, we can see what's in the atmosphere. And here you see the blue ring, which is supposed to illustrate the atmosphere. Well, what we can do is we can see the light from the star shining through the atmosphere when the planet is in front of the star. And in that way, just like shining a flashlight through a fog and seeing which parts of the light don't make it through, we can infer what gases are in the actual exoplanet atmosphere. Now, the thing is, this would work well for big Earths orbiting small stars in the future. It works well today for big planets orbiting stars like the sun, but it actually won't work for the true Earth twin. If we want to go out there and find an Earth analog and look at its atmosphere, we can't use this so-called transit technique because the Earth is just too small compared to the star. So we have to use a totally different technique. And this technique, we actually call it direct imaging. And there's direct imaging going on from the ground, but to find the true Earth twin, we must go to space to get above the blurring effects of Earth's atmosphere, at least for some types of direct imaging missions. So here is showing you an artist's conception of an Earth. And I just want to try to convey to you how hard it is to find the true Earth twin. It's not that Earth is so faint. An Earth around one of the nearest stars wouldn't be fainter than the faintest galaxies ever seen by the Hubble Space Telescope. The problem is that the Earth would be adjacent to the very, very bright sun-like star. And our sun is 10 billion times brighter than the Earth at visible wavelengths. The analogy we use is it's like looking for a firefly right next to a searchlight, when that firefly and searchlight are thousands of miles away. That's like us here trying to spot a searchlight with the firefly right beside, trying to see the firefly right next to the searchlight when that searchlight is in San Francisco. So this is one of the greatest challenges facing astronomers today. And I want to tell you about my preferred way to find Earths. There are actually several ways to do this. But my favorite way, actually, is with a special telescope and star shade system in space. The star shade is a large occulting screen that's very specially shaped. And it's positioned in between a telescope and a distant star. But the screen is shaped, actually this screen is shaped like a flower, and the starlight actually diffracts around the edges to block out the starlight to better than 1 part in 10 billion, so that only the planet light is seen by the telescope. Now the star shade and telescope have to be aligned, just so, at tens of thousands of kilometers apart. So you can see how hard it is to find Earths, tens of thousands of kilometers apart, lined up to about meters, lined up to within about meters. That's like asking a friend to hold up a dime at 5 miles away and be lined up right with you. And just for the skeptics, if you want me to later on I could explain why we think that particular part, we call it formation flying, is possible. But for now I want to show you a movie, and I want to show you how the telescope in animation and star shade could be launched together, and the petals would unfurl from their stowed position, the truss expands, and the petals would snap into place. Now the precision manufacturing on these petals has to be to within tens of microns, and there are other tight tolerances. This star shade would fly far away from the telescope, line up with the star, and it would block out the starlight to reveal the planets. And it's fair to argue that today, this is the most effective way we could use to find Earth twins with a small space telescope. So I actually am even more pleased to show you a real movie of work going on in the lab, showing you 4 real petals at 2/3 scale, attached to a truss, and a time-lapse movie which shows you the truss expanding and the petals with the second stage of deployment snapping into place. There is so much technology work going on, I couldn't even convey it all to you in the time that I have. But this work here was filmed at Northrop Grumman a few weeks ago, and it's work by NASA, JPL, Northrop Grumman, and Princeton. It's just a brief snapshot of some of the work that is ongoing. I believe that in our lifetime, we will be able to take children to a dark sky and to point to a star and say that star has a planet with signs of life in its atmosphere. That star has a planet like Earth. and I am going to be devoting the rest of my life to make this happen. And it's not just me, but here at MIT, we just finished a 2-day meeting with a team of people that I'm leading who are really among the most passionate and dedicated people I've met. And we have full confidence. We're actually studying this, the external occulter, the occulting screen. And we have full confidence that this technology can be developed from its current status through flight with enough support. But there's a larger vision here. And I want you to think back to the most memorable events over the last hundreds or 1,000 years, to Christopher Columbus as he sailed across the ocean and reached the New World and changed the course of human history forever. I like to think about people hundreds or 1,000 years from now. What will stand out to them looking back? I believe in the future, when people set sail to the nearest stars to explore the exoplanetary systems, they will look back at us and the movies I showed you, and they will remember us, collectively our generation, as those people who first found the Earth-like worlds. Thank you.